Hello, everybody. Welcome. Thank you so much for joining us today. We're really glad to have you. Welcome back to those of you who have previously joined the series, and welcome to new participants. We're really excited to have you today. I'm Bianca Mobius-Clune. I direct climate and soil health at American Farmland Trust, and we have been building up our biochar integration into agriculture and are really excited to be here today with our partners who are working on this webinar series and a number of other things with us. We have folks from US Biochar Initiative with us and from USDA's Agricultural Research Service. And I want to acknowledge funding from USDA and NRCS to make all this work possible. So thank you again for joining us. Today, we will have our fourth webinar in the Practical Biochar Implementation webinar series. And we're really excited to start getting into this topic on considerations for biochar and beef cattle systems, because we've been getting a lot of questions about it. And there's a lot of questions, there's some challenges. We want to start digging into that conversation, and I anticipate that that will come back over time as more progress is made in the space. First, a couple of logistics. As you have questions today, please add your questions to the Q&A. We will do our best to get to all of the questions during the Q&A sessions, but if we don't, we do want to capture all of your questions, because we will use those for putting out frequently asked questions documentation. We will answer those in various fact sheets that we put out. And we're just really curious to see what questions you all have, because that helps us tackle the gaps that are still in the space. Also, this webinar is being recorded today. We will be making it available on the Farmland Information Center. The link is below. We've got 3 webinars there already, and this is the 4th in that series. Also, USBI makes this webinar available on their site, so we will have it available for you in multiple places. We also have live captioning available today, and we are really looking forward to your feedback as you get through this webinar. We would love to hear from you. Was it useful? Are there things we could do better? Are there additional topics you would love for us to tackle? Are there questions that left unanswered? We want to hear all of that. So there will be a link in the chat. Also, here's a QR code to get to that link. We would love to hear from you, so please do leave us your feedback. With that, I would be remiss not to introduce American Farmland Trust. I wanted to take a moment to talk a bit about the organization. We are a nationally connected nonprofit organization that takes a holistic approach to agriculture. We work at the interface of land, the farmers and ranchers who manage that land, and the agricultural practices that they all use on that. And so since our founding in 1980, AFT has helped permanently protect over 7.8 million acres of agricultural lands. And that's our history. We are a land trust, but we have also worked on millions of additional acres to advance soil health and other conservation practices. And we work with thousands of farm families to work in the viability of farmland space and in equity. So we're really excited to holistically address all of those dynamically interacting factors in agriculture. We do our work from kitchen tables to the halls of Congress. We have a really good policy team. Things come to us, and we can really literally work with a farmer on the land to understand what is getting in their way, and then bring that to Congress, bring that to headquarters, and that's part of how we make our impact. We do our work as a combination of that policy work, coalition building. We do work on the ground, actually practically with farmers to really understand where they're at. And we also do research and technical guidance development. And we bring all of those together, and all of those spaces really kind of feed into each other and help us make a catalytic impact out there. We are working across partners and stakeholders, not just to bring about change for a better agriculture in small pockets. The goal is really to actually catalyze a transition to a new conventional agriculture, so a new normal. We're looking for a climate smart, diverse, resilient, soil health promoting, equitable, and environmentally, economically, and socially sustainable agriculture. So that's pretty ambitious. That's a lot to do. We are not doing that all on. It will take everybody here, everybody that we work with, to work together. So it is truly a holistic and collaborative endeavor. But we at American Farmland Trust really look to figure out the gaps and promote catalytic activities that will allow for that change to that new normal agriculture that doesn't get all the bad rap that sometimes conventional agriculture gets, even though we all are trying very hard. All the farmers out there really trying hard and are doing the best we can. We want to provide the tools to make that easier. So as part of that work, We work across systems, and we see biochar as a core tool in the soil health management and climate smart toolbox. And we are ready to scale that up and integrate that with our wonderful collaborators here today and others as well. We have a large number of projects that we're kicking off right now. Some are centered around biochar and its use on farms and connecting to producers and users of biochar. We also have we have 2 large partnerships for climate smart commodities projects, and both of those integrate biochar into the broader soil health management systems and climate smart adoption work. This webinar series right here is a piece of that body of work, and I hope that you today will find Andrea's presentation inspiring and thought-provoking and informative. I will just reiterate again how much we really do want you to fill out our evaluation form at the end. We really value your feedback. So with that, I'm going to turn over to Dr. Kristen Tripp. Thank you all for being here today. I will let Dr. Kristen Tripp introduce our speaker, Dr. Andrea Watson.
Hi, good afternoon. I'm here in Oregon, and I'm so pleased today to have Dr. Watson give our presentation regarding biochar use in dairy and cattle. So Dr. Watson received her PhD from University of Nebraska, Lincoln, where she majored in animal science, mostly focused on cattle nutrition. However, her research projects really spanned the whole gamut from grazing to feedlot nutrition, and even anaerobic digestion of manure. She's been a faculty member at UNL for 9 years with both a research and a teaching appointment. There, she's taught undergraduate and graduate classes, primarily focused on beef cattle production. She has advised students in distance education, applied master's degree program focused on beef production. Her research activities have really focused on nutrient cycling within agriculture and finding best ways to turn waste products into resources, which is really what is at the heart of biochar production and use. Dr. Watson is really excited to join Concordia University in January of 2024, where she's focused on teaching undergraduate students in agricultural sciences degree program. We're so grateful for her joining us today to provide this information, and I'm really looking forward to it. And with that, I'll pass it over to.
Thank you very much for that introduction, Dr. Tripp. And I will go ahead and attempt to share my screen so we can get started. So I would like to say that most of the research that I'm going to be presenting was conducted while I was at University of Nebraska. So a few of my key collaborators will be listed there as co-authors on this, and a really important collaboration there, and as well as many of the students that participated in the research and did this research as part of their thesis or dissertation project. So now you can see some of their names. So Jim McDonald, Galen Erickson, some of the key faculty that I worked with closely there at UNL, and then Hannah Kronk, Holly Heil, and Jessica Sperber would have worked on many of these projects for their master's or PhD projects while they were pursuing graduate school. I have now left UNL just as of January, so not too long ago, but I am still very excited to talk with each of you about some of the work that we were doing at UNL. All right, so on to biochar, and why were we even looking at this? Okay, so how did we get interested in this? What led us down this interesting path? So actually the US Forest Service, several people there, Adam Smith, Heather Nobert with Nebraska Forest Service that are housed there on UNL's campus, came to us and said, have you read this paper? This paper by Lang and others in 2012, we're really interested in it because they were feeding biochar that was made from rice husks to cattle. The cattle, so this paper was done out of Southeast Asia. So very different production system than what we would be familiar with here in the US or in the Great Plains region, but they were on a forage-based diet. Cassava root and foliage was the primary base of their diet. And they were feeding just over 0.5% of their diet as biochar. And this biochar, again, was made from rice husks, a common byproduct there, right, when you have rice production. Relatively small animals, so only 84 kilograms compared to, again, as I start to show some of the animals that we were using, they're over 300, over 500 kilograms. So much bigger animals here. A unique breed, so they're kind of a local yellow cattle is what they're called that they were using, compared to our, Angus, Hereford, Charolais crosses that we see here in the US. Relatively low weight gain, okay, which is not unusual on a high forage, fairly low quality diet, very low weight gain, very low intake. Again, these numbers jump out when you're used to Nebraska systems or US systems and seeing much bigger animals and bigger eaters. But what they saw was an 18% improvement in efficiency. So what that means is that the cattle could consume the same amount of feed, but gain 18% more in order to be more efficient when they had biochar in their diet. Okay, so just a small change in the diet, adding biochar resulted in an 18% improvement in efficiency, which is really huge. And also, what we're going to talk most about today was that 24% reduction in methane that they saw. Okay, so they were specifically looking at this as an environmental greenhouse gas solution. So everybody's familiar with ruminants, cattle, sheep, goats, those animals that have a rumen and they expel methane, right? It comes from the rumen. It's part of the digestive process of breaking these feeds down. Methane is produced. It has to be expelled from the rumen or eructated, burped out in order for fermentation to continue. So we're all searching, all of us ruminant nutritionists, searching for a way to reduce the amount of methane that they're expelling because of its potency as a greenhouse gas. So very excited about this result, that it was a 24% reduction in methane. So they came to us, and that's how it originally started. US or the Nebraska Forest Service came to us. We found additional funding through the US Forest Service, the Nebraska Department or Nebraska Center for Energy Sciences Research, funding from all three of those sources in order to do the research that I'm going to be presenting, because we wanted to follow up on that. I highlighted a few key differences, right? We always wonder, results that are really exciting in one location, will that translate into our system, right? Our system is so different in terms of the feeds that we're using, the cattle that we have, maybe the biochar that we're producing, because the byproducts that we're turning into biochar are different. So let's look at it in a Nebraska-based system or a US-based system. Okay, so we looked at both forage diets and grain-based diets. So kind of a grazing type of diet, so to mimic cattle out grazing on a high forage diet, as well as when we transition cattle over to a feedlot and feed them a lot more concentrate, more grains, and wanted to look at the interaction there, right? Is there a benefit in one but not the other, or a better benefit in one or the other? Key collaborators would be Vital Ag out of Nebraska, High Plains Biochar, and then V-Grid Energy. So three really important biochar companies that we partnered with in order to test some commercially available biochars in this idea. Really important to point out that biochar is not currently approved to be fed to animals or to be fed to cattle. Okay, so in order to do this work, we started off really small, but as we got more animals enrolled in it, we wanted to actually harvest those animals. So we got what's called an FDA waiver, a food use authorization from the FDA before we started these experiments, so that we could do this under FDA's guidance, because commercially currently it is not approved to feed biochar to animals. So that's kind of a stumbling block right now for anyone that's actually wanting to implement this. Okay, in order to do that, basically had to be very specific about the animals and the biochar that we would be feeding, the diets we'd be feeding it in, those sorts of things. Tested it for toxins, things like dioxins, furans, some heavy metals like cadmium, lead, arsenic, mercury, all those types of things. Everything came back non-detectable for all of the biochars that we tested. But again, important to point out that we did go through that process in order to do this under FDA guidance. Okay, so as we first started, we started small, right? So wanted to pursue this idea in a very small way. We used head boxes. So here's a picture of what our head boxes look like. And so literally the head of the animal goes into the box. Okay, this works because over 97% of the methane that comes out of a ruminant animal will come from the head. It will be eructated or burped out the front of the animal. So you don't have to encompass the entire animal in order to get fairly accurate results from methane emissions. Okay, so we put the head of the animal in there for 23 hours. Their feed, their water is in that box with them for that period of time. So we can only do this with a few animals, right? So we had 6 animals enrolled in this study, and they could only be in there for 23 hours. We could take them out and then bring them back in at a period later, right? So we cycled them through a few times, but fairly limited just to get a feel for how this was working. The second way that we did this, then once we saw those results, wanted to further test it, now we scaled it up to hundreds of animals. Okay, so UNL has what they call their methane barn, which is basically 2 chambers. They call it the west chamber and the east chamber. And into those chambers, you can put a pen of cattle. So now we're not talking about single animals. Now we're talking about a pen with 8 animals in that pen. So all 8 animals will go into this chamber. The entire animal is in there, right? So now we're not only talking about methane being burped out, but also emissions from the manure and everything. So the whole pen of animals, and they could be in there for 5 days. Okay, so just a lot more robust measurement here, where we have 5 days worth of measurements. We have 8 animals, all of that in order to make more accurate and precise measurements. Okay, so again, just have a constant airflow, very similar to the head box. We have a constant flow of air through these chambers, whether it's a head box or this pin. We know the flow of air, measure methane concentration, as well as CO2, carbon dioxide concentration in that air, in order to then calculate how much methane or CO2 is being given off by each animal. All right, the biochar, I'll just quickly go through. We attempted to characterize the biochar that we used. So I have several different ones here. We did try several different diets, several different biochars. So the first from High Plains Biochar, particle size, roughly half of it was between this 1.18 to 3.35 millimeters. So picture here with a quarter in the image to kind of give a feel for what this looked like. Fairly consistent size. It was 70% dry matter, 85% carbon on a dry matter basis. Surface area was 323 meters squared per gram, a bulk density of 88 kilograms per meter cubed, and a pH of 8.0. We'll contrast that then to a second biochar made by High Plains. So we had some results from that first one and then tried to maybe tweak the production process just a little bit. Our particle size was 66% of it was less than 2 millimeters, and only 1% of it was bigger than 4 millimeters. Again, so right here with my pointer, I'll try to circle within the diet. You can see, so this is the diet, right? We've got some corn, some wheat straw, and different feeds, and then you can see the little particles of biochar in that diet as well. So mixed in really well with the diet. This biochar, again, we had to go through an FDA waiver in order to do this research. And so part of our FDA waiver was that the biochars that we used would be made from ponderosa pine. And so we did have to limit our feedstock in all situations to ponderosa pine. This one was 83% carbon, a bigger surface area, so 426 meters squared per gram, bulk density of 108 kilograms per meter cubed, and pH was a little bit higher as well at 9.5. Excuse me. All right, our next biochar then made by V-Grid Energy Systems out of California. This one was made from pistachio shells, okay, going through a gasification process, so very different product. They've actually received some approval individually for their product, a very small particle size, okay, so less than 0.5 millimeters. This picture, maybe I don't have a quarter or something in there to show the size, but a very small particle size, almost a powder. Carbon content of 85% on a dry matter basis, surface area 217 meters squared per gram, and a bulk density of 381 kilograms per meter cubed. pH, again, fairly high at 9.3. And then our last biochar here made by Vital Ag, which would be a smaller company here in Nebraska. Also, again, made from ponderosa pine. Particle size was quite a bit bigger. So about 50%, half of it was 4 to 8 millimeters. So much bigger particle size. Still high dry matter, high carbon, so 74% carbon. Surface area a little lower at 181 meters squared per gram, and bulk density at 151 kilograms per meter cubed, and a neutral pH at a pH of 7. This one, because of the bigger particles, we were a little concerned, you know, are cattle going to pick that out of the diet? Does it not mix in quite as well? But again, the biochar is so fragile, so as we mix it into the diet, it really gets processed down very nicely to be fairly small particles, and did not see any sorting of the cattle by the biochar in the bunks. Had them consume it with really no problems. Okay, so just an idea then of what our diets looked like. So this first one, the diet that we used, the very first thing we did was those head boxes. So we fed a growing diet, which would be a forage-based diet. So kind of mimicking cattle that are out grazing pastures. So we used 21% brome hay, which is just be a grass hay, 20% wheat straw, 30% corn silage, which would kind of be a half grain, half forage, some wet distiller's grains coming out of an ethanol plant, a little bit of supplement that contained our vitamins, our minerals, and fine ground corn, and then possibly most important here, our levels of biochar. So we had our control treatment that had no biochar, an intermediate at 0.8% of the diet being biochar, and then all the way up to 3% of the diet being biochar, again in this growing diet. So results, what did we see when we fed biochar in this forage-based diet? Okay, so right up here, the first line, DMI, would be dry matter intake. How much feed did they consume? And my p-values over here basically tell us if these are statistically significant or not. So the bigger the number, the more likely that these numbers are all very much the same statistically, okay, numerically and statistically. So the smaller the number, the ones that I have highlighted or bolded here, the 0.06, the 0.05, are ones that we maybe want to look into more closely. The ones that we said, hey, there might be something going on there. There might be some differences due to treatment on those. 0.11 here, right? That one's kind of intermediate. That's an uncomfortable space where, well, there might be something going on, but we're just not for sure. So we had feed intake, dry matter digestibility. So how much nutrients could the cattle get out of their feed? I'm going to call that one not significant. So basically no effect, which again is a positive in that biochar didn't reduce diet digestibility, but didn't seem to help either. With the 0.11, it's a quadratic. So it means it might have come up a little bit here at the 0.8. Methane, our p-values suggest that's not different. So methane, we measure it two different ways. Right here, methane in grams per day. So just how much methane is being eructated by the animal. And then if I jump down here, also how much is being eructated relative to how much they ate. So the best way to reduce methane emissions from ruminants is to reduce how much they eat. If we cut their feed intake, they will produce less methane, but they'll also be less productive, right? So if they're a feedlot animal, we cut intake, they're going to be around for more days before they get finished. Or if they're a calf, right, they're growing more slowly. So we don't want to just reduce this line here, just grams per day. We're really interested in reducing methane relative to how much they eat. So we call that methane intensity. So we want to reduce this and really saw nothing in terms of methane. So we did not reduce methane, interestingly, with this diet and this type of biochar. We do see a little bit of a blip here with my p-values that I have bolded, right? That CO2 production actually was reduced a little bit with the intermediate level of methane, or sorry, level of biochar, right? We see just a little bit of a dip there. We then followed that up with that finishing diet, so more of a feedlot type diet, a higher energy, more grain in the diet. So now our diet is 53% corn, 15% corn silage, so only a little bit of fiber or roughage in the diet, 25% distiller's grains, our supplement, and then the same inclusions of biochar. Our control with no biochar, 0.8% or 3% of the diet being biochar. What did we see? I'll go through the same lines here, but I'll spare you the suspense. If you look over here, I don't have any bold numbers, meaning all of these were statistically the same. We did not see any impact of treatment, diet, right? The amount of biochar aren't on any of these parameters. So they ate the same amount of feed, they digested it the same, they had very similar methane and very similar CO2 emissions. Okay, then we thought, well, okay, so that's head boxes. That's one diet, right, that we're able to test. Only really two levels of biochar. Let's dive into this a little bit further. Also only, one type of biochar. So that's when High Plains came back with a different biochar, attempted to increase the surface area of the biochar. We went to the methane barn, again with a growing diet and a finishing diet. So remember, now we're at 8 animals per pin. We had 8 pins for each treatment, so a lot of good replication. So we had a total of 128 animals now instead of just 6. Okay, again, this is a growing forage-based diet, so a lot of wheat straw, corn silage, a little bit of distillers. Most important here, the biochar line, we had just the control with no biochar, and then our 0.8%. We stuck with that 0.8% of the diet as biochar for our treatment. Switched those animals, so kept the exact same animals, but switched them up to a high energy finishing diet. So about 54-55% corn, some sweet bran, which is a product coming out of Cargill's wet corn milling plants, a little bit of wheat straw, and again, biochar. Now we went up to 1%. So we went from the control, no biochar, up to 1% biochar in the treatment. Okay, we did this actually 3 times. The growing diet, we only repeated 1 more time, but then this finishing diet, we varied the diet just a little bit, and we used the different biochars that I went through before to look at different biochars, a little bit different diets, those sorts of things. And I will not go through each of those tables in detail, just in the time that it would take to do that, but I can give you kind of the brief overview here. So my p-values, I don't have any of these bolded, so none of these were significant. So what were we measuring? On this slide, we're measuring animal performance. So how much did the animals weigh? How much did they eat? How much did they gain? How much weight did they gain every day? And what was their feed efficiency? So how much feed did it take to put on a pound of gain, basically? So all of our animal performance measurements were the same. No matter if it had biochar or did not have biochar in the diet, we did not see any impact on animal performance. What we were really interested in was the methane and CO2 piece. Okay, so in addition to measuring animal performance, we're also measuring their methane and CO2 emissions. Again, no bold numbers on here, no significant p-values, meaning we did not see an impact of treatment on methane emissions, whether it was grams per day or grams per kilogram of intake. Same for CO2, okay? So we're not seeing an impact, interestingly, by feeding biochar, okay? So remember, this is kind of scratching the surface. This is just kind of a typical Nebraska or Midwest Great Plains region diets. So we attempted to do both a forage-based diet, right? We didn't have cattle actually out grazing pasture, but mimicked the quality that they would get out in a pasture by using some forages. And we also did feedlot finishing type of diets. We only were able to do those few biochars, right? We don't have a lot of control over how the biochar is produced or how to make the biochar, the product that it's coming from, right? With our FDA waiver being fairly limited, we can't do a lot there, or we haven't yet been able to do a lot of changing in order to look at it in a really big way, right? Okay, we fed it at 1% of the diet or 0.5% of the diet. Okay, so we again tried to vary that a little bit within a fairly narrow range, but look at some different things. So questions that still remain is, how much should we be feeding? Where is it most effective, right? What size of animal, what type of animal, what feedstock should be used, right? It's really hard here, the chicken or the egg, the cart before the horse, those types of things, right? How can we develop a biochar for a specific use if we don't have approval to use it and things? So it's really difficult at this point to spend the money basically to develop a biochar that this application if there is no application for it, right? Where we are not currently able to actually feed it to animals in this scenario. However, have to reiterate, with the ones that we tested, the animals, the diets, the amounts that we tested, those biochars, we did not see any improvement in animal performance or any reductions in methane emissions. Which takes us then, in my last bit of the presentation here, I'm going to transition, and instead of talking about feeding biochar to animals, actually using it as a manure amendment. Okay, so a little bit of history here, feedlot diets. So in our feedlots here, where cattle are consuming a high energy, sometimes fairly high protein diet. Protein of that diet is usually somewhere between 13 to 18%. As ethanol production is taken off in the Midwest and we're feeding more distillers grains, maybe we're closer to that 15, 16, all the way up to 18% protein if we're feeding a fair bit of distillers grains, because it's a really good protein source for the animals. Our phosphorus levels also go up as we feed some of those products. We do a really poor job in animals in general, our bodies, whether that's you and me or cattle, of actually maintaining those nutrients within our bodies, right? Our bodies require a fair amount of protein, a fair amount of phosphorus, but most of it passes right through. Okay, so we only, in a feedlot type of situation, we will only retain 12 to 18% of the nitrogen and phosphorus that we feed in the body of the animal as they grow in their muscle and their tissues, and the rest is excreted. Okay, so we are excreting nitrogen and phosphorus onto that pin surface. As Dr. Tripp introduced me, my research was really hinged on trying to capture those nutrients within agriculture, right? Pairing crop and livestock production in order to best capture those nutrients within the manure as a fertilizer source. Okay, so organic matter, carbon on that pin surface does trap nitrogen, kind of acts like a sponge and traps that nitrogen. We know this. So the question is, could biochar, as a really good carbon source, help us to trap more of that nitrogen, especially, which is our biggest need for our crops, is the nitrogen fertilizer. It's a really big expense for farmers, huge energy expense for the country in making synthetic fertilizers, synthetic nitrogens. So could we improve our manure fertilizer value by trapping more nitrogen in it? Okay, this would be a benefit for a couple of different reasons. The obvious environmental benefits, that nitrogen going off into the air as ammonia or into water as nitrates, right? So we have both air and water concerns with nitrogen, depending on what form it's in. And then also just the economic value of the manure, right? Not losing that nitrogen, but actually capturing the value of it for the producers. Okay, so what did we do? We took biochar. So in this case, it was a very unprocessed biochar, kind of a simply made biochar, maybe, if I could describe it that way, coming out of Sawmill in Springview, Nebraska. In this case, we're not feeding it to the animals. We're simply putting it out onto the feedlot pin surface as an amendment. So FDA approval now is not required. We're not feeding it to the animals. Fairly large particle size. Okay, so most of it is going to be bigger than 8 millimeters. And interestingly, one of my favorite pieces of this is that it's made from eastern red cedar trees. So if any of you live here in the Great Plains or have been following, we're really fighting a war with eastern red cedar trees. They're taking over our rangelands and are an invasive species. So anything we can do to clear those eastern red cedar trees to keep our grasslands intact, what do we do with those eastern red cedar trees? So one benefit or one use of them would be to make them into biochar. Okay, so that's what they did. They took eastern red cedar trees, made them into biochar, and then we spread that biochar out onto the pin surface. A little snapshot of what that biochar looked like: 80% carbon, 233 meters squared per gram, 9.7 kilograms per meters cubed, and a little bit lower pH at 6.3 for this biochar. We did 2 different experiments on this one. A winter feeding period, so the cattle entered the pins in December and were harvested in June, and then followed that up with a summer feeding period where the cattle started in June and were harvested in November. Okay, so here's the biochar. Basically, we would weigh it and then put it into the skid steer bucket and then spread it out onto the pin. So right here, you can really see the difference, right? That biochar giving a nice black color to the pin surface. So this here with the cattle would be showing a pin with biochar. And then this one here is a control pin with no biochar. So we did this with 10 pins, 5 on each treatment. There were 10 or 8 steers per pin, depending on which feeding period we're talking about, and just those 2 treatments, with biochar or without biochar. And our objective then was to look at nutrient retention, so nitrogen, phosphorus, and also carbon in the manure, as well as we're always interested in cattle performance. So how well did they gain? How well did they eat? How well did they convert that feed into gain by these treatments? Okay, so here's some pictures of that actually happening. Jessica Sperber was the PhD student at the time doing this work. So here it is at the very end, using a box scraper and a skid steer to clean those pins after the cattle are gone, coming in, piling that manure at the front of the pen on these concrete aprons in order for her to come in and sample the manure extensively as it's loaded out and hauled to crop fields to be spread. What did we find? All right, so in the winter phase, so when cattle were being fed in the winter, it was roughly 186 days. We saw no differences in animal performance, which was not overly surprising. We didn't really think that spreading biochar out on the pen surface would result in animal performance. But unfortunately, also no differences in our manure nutrient amounts. We did not capture more nitrogen in the manure, or more phosphorus, or more carbon. We had roughly 55% nitrogen losses from that manure, which is right on par with industry average. In the winter time, we'll see 50 to 60% losses. So that all made a lot of sense, but unfortunately not a benefit of the biochar. Now, it is one thing that we did see. So here I've got my p-values. They're less than 0.1, approaching 0.05. So some interesting results here, some differences due to treatment. So what I have here is organic matter content of the manure, or basically carbon content. And you can see it's a little bit higher for the pins where the biochar was spread. And then the same for the nitrogen. Okay, so we are increasing just a little bit here the concentration of nitrogen and carbon in that manure, which is a benefit. We want those nutrients in the manure. Remember, I said no differences in amounts. So pounds of nitrogen, pounds of carbon hauled out of the pin were not different between treatments, but the concentration of them was slightly different, which means that we hauled more total pounds out of the control pins. Okay, you can see here the pins, we just have this short concrete apron for them to stand on while they're eating, and the rest of the pin is a dirt or soil surface, right? And so if we're hauling more pounds out, that means we have ash contamination or soil contamination in with our manure. Our objective when we're cleaning those pins is to go very lightly across the top and just get the manure. That's impossible to do. Even people much better at cleaning pins than I am, it's impossible to get just the manure, right? But anytime we can increase our carbon and our nitrogen content, it means we did a better job of cleaning those pins, and we were able to just get less soil in with our manure. That means less loads having to be hauled, so less diesel used, less traveling on the road, less to spread out on the crop field. So all those are benefits if we can concentrate those nutrients just a little bit. So kind of thought, well, was that a fluke? You know, what happened there? So we followed it up with the summer phase. I'm going to go over this a little bit quickly and come back to it, but we saw, remember, there was no differences in animal performance in the first phase. Here in the summer phase, we saw a 17 kilogram improvement in final body weight. Okay, so those animals that had biochar on their pins weighed 17 kilos more than the control treatment. Okay, with that, they had a 4.5% improvement in efficiency. Okay, so they ate the same amount of feed, but they had a greater body weight gain. This was surprising to us. Very similar now to the last one, no differences in manure or nutrient amounts, what we were thinking would actually happen, and still 70% nitrogen losses from manure. Again, very industry standard in the summertime that we'll see about 70% nitrogen losses. But again, I'm showing significant p-values here, or approaching significance, where our carbon content and our nitrogen content of that manure just a little bit higher for those pins that biochar was spread on them. Okay, so again, this wasn't a fluke, it looks like. We were able to more successfully clean those pins. Perhaps the biochar absorbed moisture. That's not hard to believe or too big of a stretch, right? For you that's been around biochar, it does that really well, which made the pins a little drier and a little easier to clean. That's one possibility. There's also that visual, right? I showed that black layer on these pins. You could see maybe the interface a little bit better, where the manure was and where the soil base of the pin started. Maybe that made it a little bit easier to clean pins. Not exactly sure, but basically we hauled more total pounds of product out of the control pins, less pounds, but more concentrated carbon and nitrogen. So that's a real benefit there. So we saw no total differences in pounds of manure nutrients, but we did see a concentration of those nutrients in the pounds that we were hauling out. Okay, back to the improvement in animal performance, a little bit unexpected. Our best guess, we did not have soil moisture probes out in those pins. In hindsight, wish we would have. But in this case, our summer phase, usually our summer is going to be a very dry period. Interestingly, we've had some really wet Julys in Nebraska, which is unusual. But this was one case where we had an exceptionally wet July. So our pins get muddy and sloppy, and animals have to use a lot of energy in order to walk through that mud to get up to the feed bunk and different things. And so if we can actually reduce moisture in those pins, have a little bit better pin integrity, or the surface of that pin drying out more quickly, basically just less mud, that's a real benefit to the animals, which could show up as a improvement in energy use, basically. So this improvement in efficiency, improvement in final body weight. Can't prove that at this point. We didn't collect the right data to really dive into how that happened, but that's my best guess at this point as to what happened and how we saw that improvement in efficiency. All right, so overall, I think when we're talking about biochar and integrating it into beef cattle systems, we really have to closely weigh the costs and benefits. Okay, so obviously there's the cost of actually buying the biochar and whatever practices you have to put into place to ensure that it's being either spread onto the pins or fed to the animals. On the benefits side here, the two benefits that we were looking at, hoping to be able to measure, were methane reduction and then this recycling of nutrients, better able to capture nutrients within the manure. Neither one was a total success. Methane didn't happen. We did not see a reduction in methane when we were feeding biochar. Again, there are plenty of drawbacks from feeding biochar right now, the most important being that FDA clearance and safety piece, right? FDA's task is to make sure our food supply is safe. They do a really good job of that, and we want them to continue doing that. So we've got to make sure that it's cleared through FDA before we feed it on a wide scale, other than in just research practices where we have those waivers. We want to make sure digestibility or performance is not hurt, which we showed repeatedly in our experience. We did not see any harm on performance or digestibility of nutrients. We didn't see absorption of key nutrients, any nutrient deficiencies, right? So these two I'm not too worried about. The top one and getting FDA clearance, I think is still the biggest hurdle. But with no benefits on the methane side, hard to drive forward and ask for FDA clearance. The less difficult thing, the low-hanging fruit, is this recycling of nutrients. So we are able to currently use biochar, apply it to soil surfaces, and really the biggest thing there is now it's incorporated into the manure and can be spread out on crop fields. So probably all familiar with some of the benefits or research going on with biochar and implementing it into cropping systems. One really great way of getting it into a cropping system would be as a manure amendment. Okay, so last slide here, basically kind of summarizing what I was just saying. We didn't see negatives on performance, animal performance when feeding it, but no benefits either. There are several other research studies out there, mostly coming out of Canada, because they have easier pathway to feed biochar in Canada, but also no methane emissions there. So kind of thinking these North American type of cattle, these North American diets, we're not seeing that benefit on methane emissions. But on the manure amendment side, that animal performance in the summer was unexpected, but very, very real. The pin integrity differences, unexpected again, but that did help with our muddy pin conditions. There are soil benefits, right? When we get it out into the crop field, this would be one way, right? Just bringing that biochar into the system one step earlier into the manure instead of directly applying it to the crop field. How we apply that right directly to the crop field or as a manure amendment remains to be seen. But with that, I will wrap up, and I think we still have plenty of time for questions.
We do, in fact, have plenty of time for questions, and we have received a number of questions in the chat or in the Q&A. And also, I would like to encourage everybody who is on, thank you again for joining us today, to ask questions about the research that Andrea just presented or anything related to it that you're curious about. And I will start with some of the questions that we got here. So one of the questions that I see is around biochar and animal health. Question is, did you monitor any animal health impacts? I know of a dairy farmer in Ontario that claimed it had reduced the frequency of aborted calves and attributed it to possible improvements in gut health. Wondering if you have any thoughts on that.
Good, yeah, good question. We did. So in all of these experiments, we would have monitored morbidity and mortality. So the incidence of sickness as well as incidence of death. And there were no differences. So we did not see any impact. We certainly didn't see any health concerns with feeding it, but we didn't see any improvement. Now that's not overly surprising probably because these are really healthy animals to begin with. So we aren't bringing in high risk. These are all Nebraska cattle. So they're probably about the top of the chain as far as healthy, received really over a significant period of time, everything we can do to keep them healthy. So we are not bringing in high risk calves. If there is a benefit, I would expect it to be in those high risk animals, the ones that are seeing more morbidity, mortality, right? So we have really low sickness levels, really low death levels at this particular research feedlot. So it's going to be pretty difficult to see improvements or changes in health outcomes because of that. And then the other part, the abortions specifically. So we didn't have any cows on this. We only had steers. Let me think now. Yeah, only steers, not even any heifers. So all calves basically that have been castrated. So steers on all of this, we had no reproductive performance at all. We were not trying to breed or get live calves or anything. It was just performance in terms of weight gain. But really important question. Certainly some interest in a lot of claims, especially coming out of Europe on the health piece, but pretty difficult to study extensively in this system.
So you're not familiar with anybody else who's done studies in that realm? Do you have any thoughts on that, or those folks in Europe who are doing studies in that area?
Yeah, I would just say health in general is really difficult to study. So most of that is going to be kind of anecdotal evidence kind of reports. So basically saying, the type of literature that's common in veterinary journals, right? So this is what we did, but there isn't a control to compare it to. So certainly some evidence there that feeding biochar, if there was a toxin or some other pathogen that they were trying to combat, that maybe it had some benefit. But I am not familiar with any kind of controlled clinical trials where we have a treatment basically compared to not treating animals.
Thank you. Let's see, other questions we've gotten. One question is, do you have plans to study the soil and forage production benefits of feeding biochar to cows?
Good question. I have a lot of interest in that. I probably won't pursue it with the job change. I'm not currently active in a research setting any longer, so I don't have the resources. I took that for granted for a long time, right? At UNL, you have tremendous research resources around you at all time to pursue ideas like that. I'm hopeful that UNL, there are a number of people there, Dr. Michael Kaiser in the agronomy department, Dr. Amy Milner-Schmidt in the kind of the engineering, biosystems engineering world, have a lot of interesting and exciting research going on in that space. So I think there will be things coming out. I personally won't be involved in it, at least for the next few years, while I focus just on teaching.
Let's see, we've got all sorts of good questions coming in here. One of the questions is, oh, I'm seeing that one twice. What are the expected mechanisms in feeding biochar? How does it react in the rumen? It has been said that it behaves like roughage. Feeders observe that animals consume less roughage when consuming biochar free choice. Do you have any thoughts on the mechanisms of biochar and how that interacts with methane emissions and everything else you've studied?
Right, yep. So a couple of different theories. Again, talking theories now instead of things that have been proven, because there isn't a lot of hard evidence yet on exactly what's going on, but theories that are out there. First, I'll touch on that piece about it acting like a forage. So I showed pH of the biochars that we were feeding, and they were all basic, right? They were neutral or basic, so a relatively high pH. And that's what our roughage is doing in the rumen, is helping to offset the acidic environment. So as fermentation happens in the rumen, it's anaerobic, and what's being produced are called volatile fatty acids. Okay, so those are acids, and it's constantly reducing pH in the rumen, and we want to maintain a higher pH, a 6 or up, in order to maintain rumen health. So anytime we feed a basic feed like biochar, even though it's relatively small amounts, right? Our forages are 25 to 20% of the diet. You know, on some of those diets I was showing, biochar is just a small piece, but it's fairly basic. It's much more basic than our forages. So it does help with that kind of as a buffer. So sometimes we would feed calcium carbonate or other things as a buffer to help to alleviate that acid load in the rumen. So I think it does have a role there. And that's especially true in the feedlot setting. So when we're talking about feeding a high energy, high grain diet. As far as methane emissions, so how might it actually interact with methane and reduce emissions? One would be that it's absorbing the methane, so kind of the methane sticks to it and can't be eructated then, so it passes out of the digestive tract, coming out in the feces with the biochar. That one's kind of been disproven a little just because of the very small amounts of biochar that we're feeding. There really isn't enough surface area. Even when we're talking about these huge surface areas of biochar, still isn't enough surface area to really have these kinds of impacts on methane. And so what's more likely is it's probably interacting with microbial populations in the rumen. Okay, so developing what's called biofilm, or really just this habitat for microbes to come together and do cross feeding. So the microbes that make the methane then being in close proximity with other microbes that consume the methane and make it into other products. So that's what we really want to see in the rumen, is a really healthy microbial environment where one microbe's waste is in a feed source for the next microbe. So that's kind of my best theory at this point, reading through the literature, somebody else's theory, but the one that I've latched onto is just better microbial populations in the rumen. With some of the experiments that we did, we were able to take rumen samples, but that data still coming to see what actually is going on. Did we change the methanogens, the populations of those that are creating methane, or some of the other populations? So I think more to come on that.
That's really interesting, Andrea. I wonder, as a follow-up there, if there are theories out there right now, if anybody's working on different types of biochars, both in terms of the surface area, increasing that, and in terms of providing that habitat to different kinds of microbes, or even any kind of microbial inoculation of biochars. Is there anything going on in that space to really kind of target a specific biochar for this purpose?
Yeah, good question. I hope so. I don't know specifically. So people on this call may know a lot more about biochar, do know much more about the biochar production, right? How can that be tailored? Number of really good papers out there talking specifically about the production process and how that can be manipulated in order to kind of tailor make these biochars. So in my head, I always thought, yes, this could definitely be happening or could happen, but it would take an engineer, somebody much more versed in that than I. Maybe that's happening. I'm not aware of anybody that's started to do that specifically for methane emissions, but it certainly could be happening.
So that is something to look out for. It sounds like
Exactly.
a really interesting space. Now, that being the case, right, we can't actually feed any biochars in the US, at least right now. So obviously that's a hurdle. On the side of manure, when it comes to reducing methane emissions or nitrous oxide emissions, I know there's a lot of conversation out there about adding biochar to manures in various different systems. Is there more to be told there in terms of what kinds of systems you add the biochar to, lagoons, for instance, in comparison to feedlots and pack? Do you have any thoughts on that?
Absolutely. Yep. Good question. So when we're talking about methane emissions, California especially comes to mind, right, with all of their dairies and the just really success story of them converting their anaerobic lagoons on their dairies into covered lagoons. So there is a tremendous amount of methane production from that manure waste when it's held in a lagoon, which is a wet anaerobic environment, which really maximizes methane production, which is a good thing if we're capturing that methane as an energy source. It's a negative if we're just letting it be released into the environment, right? So big success story there in California. They put up some incentives, right? Cover your lagoons, capture that methane, and that's being done in a very large scale there. So Definitely, when we're talking about manure, we're going to have the most methane emissions from our manure when it's in that anaerobic environment. So things like lagoons that we're familiar with dairies or swine facilities. And so there is a fair number of researchers out there looking at using biochar as some sort of a cover or an inoculant into their lagoons to try and capture more of that methane there, as opposed to really not much being done in the feedlot space because of the challenge of the extensive pin surface now that we're talking about, the extensive amount of time that it's out there. And it's a real challenge to get that biochar mixed into the manure in a successful way while it's still out on the pin surface. So I'd say much more work being done in the liquid manure storage systems of dairies or swine facilities.
Thank you. Let's see. Folks out there on the line, I know we've got John on the line from USBI. You may have questions, and I'm looking through here for any additional questions that we've gotten.
Yeah, I thought that was sorry about that. I thought that was a fantastic presentation. I am curious if you're aware of any of those recent studies done at UC Merced in incorporating biochar into the manure for dairy cattle in order to do the methane reductions.
I am not familiar with that particular one that you're mentioning. Do you want to share some details on it?
Yeah, they found basically about a 90% reduction in so no feeding of the biochar to the animals, but they did a 20% by volume treatment, and they found a very significant reduction in the total methane release from the manures. And then the composted manure they did a study on as well and found that it had a high level of retained nutrients. So I was just curious if you had any crossover in that space. It seems like there's still lots of opportunities for study.
Absolutely. I keep thinking we're just scratching the surface here on what could be done. And as you're saying, the low hanging fruit, no hurdles really to implementing is the manure applications.
Yeah, and funding for the studies, I think.
Well, okay, some hurdles.
let's get that funding.
That's always a challenge, right? Yeah, we'll need to get more funding in that space. I found another question, which is some folks who are interested in spreading biochar onto pastures by feeding it. I know in the US we can't do that right now, but do you have thoughts? Do you have any studies, information to share on how one might do that and what the benefits might be?
Yeah, interesting. And I've heard people talking about that. Yep. So as you feed it, it is basically inert, and meaning it's not digested. So it does end up in the feces. So that is one way of incorporating biochar into manure, would be feeding it. One caveat to that, I would say, is we're feeding such small amounts relative to how much we at least spread out on the pin surface to incorporate into the manure. So I think if you're feeding it, it's really challenging to get enough into the manure to have a very big impact compared to how we were mixing it in with the manure. Most of the studies I'm familiar with are mixing it into the manure at much higher levels than you would ever get just by feeding it.
Yeah, absolutely. Because when you mentioned that you fed 150 grams, I quickly went outside and measured, and it was 6 cups or 1.45 liters of dry pine biochar to equal to 150 grams. So yeah, that is not much biochar to get in soil if you're going to spread it that way. Of course, it would be fully inoculated. Yeah. So of course, that would be some really nice, inoculated biochar. So performant, but difficult to be evaluated as meaningful at that level of implementation to the soil.
Got another question here. Someone wondering whether the FDA has seemed interested in improving biochar as a feed additive, or whether there's been more resistance to that, what the concerns are, that kind of thing.
Yeah, I can give my thoughts, kind of my take. I've talked some with FDA when we went through that waiver process and things. For me, they were very receptive. biochar at one time was approved and then was removed from that list, basically. And to me, their major concerns was that biochar is such a very broad definition. It's such a big category now. It could be made from so many different things. It could have a lot of different characteristics, could have some toxins in it. Sometimes we're making biochar out of manure, for instance, or something, right? And so our toxins or our heavy metals, right? That's what they wanted us to test for, could keep getting more and more concentrated. So those were their primary concerns when I talked with them. It felt like they would be very receptive if there was a company that wanted to come forward with a specific product. So this biochar product could possibly get approval. They were more interested in that pathway than just a broad biochar category getting approval. That was my take from it.
That's really interesting insight, because that leads me to another question that I saw in there about, right, what kinds of characteristics might be the beneficial ones, and there's sort of a similar question here then. What kinds of characteristics might make there be fewer concerns? And it sounds like no heavy metals, no other toxins. Is there a way to perhaps come up with standards for biochars that meet some kind of specifications for feeding? Does that sound like a way that we could go?
Absolutely, yes. And I think USBI is kind of leading the on the forefront of that, right? Coming up with standards to be called biochar, and maybe developing categories for biochar, one of which might be feeding to animals. So definitely feedstock going in is going to be an important consideration. When we were talking to biochar producers, engineers, what we're focused on, some of the things that I showed: pH, surface area, maybe bulk density, those types of things. Again, that's really surface area. We didn't dive into this nearly as deeply as needs to be done still. So a lot to be learned in that area.
That is very interesting. Let's see, what other questions are there? Someone asking, did you analyze the nutrient retention in biochar that came out in the animal?
So in those manure, excuse me, manure nutrient studies, we had total mass of product coming out. So it was soil from the pin, as well as manure, as well as biochar, all mixed together. So we did not attempt to pull those pieces back apart and look at biochar specifically within the total mass. So it was just carbon, whether it came from carbon from manure or carbon from biochar, wherever it came from, we were lumping it all together in those.
Thank you. Well, I want to acknowledge the time. It's 4:02. There are probably some folks that need to go. So I want to make sure that we capture everyone's feedback. So I want to put up our QR code here again. Anybody who's been on, we would love to hear from you. The survey is right here. You can simply take your camera, point it at this QR code right here. Also, the link is in the chat, so you can click on that. We would love to hear from you. Thank you, Andrea, so much for the awesome presentation. It's been really interesting. If anybody wants to stick around and ask some additional questions, we can stick around for a couple additional minutes. I've got time, several others have time, but I do want to make sure that those folks who have been with us all along have a chance to go if you need to go. Do complete that survey. Also, we are having the next Practical Biochar Implementation webinar. That will be on April 17th, and it will be a live conversation, a little bit different from this here. We will have 3 or 4 biochar producers who will all be in conversation with a moderator from USBI. And so that should be really interesting discussion on the production of biochar. So we look forward to that. We would love to have you again. And if you joined today, then you will get an email from us. So with that, I want to thank everybody, and then I will turn back to some questions. Just want to see if there are any additional questions that I missed. Let's see, others. I know there's a couple other folks looking at our questions. I'm going to take down the screen share again so that I can see a little better. Let's see. Someone's asking about whether you've heard of Doug Howe's work feeding biochar to cows in Australia. Do you think occasionally feeding cows straight biochar mixed with the molasses could negatively affect animal health?
Yeah, really good question. So again, I'm surface level familiar with Doug Powell and a lot of the work that he's done there. Australia obviously having different regulations and things than we do have here in the US. A lot of work there with dung beetles and excitement about getting that dung down into the soil where it can do the most benefit. Again, I don't see any negatives, right? From what we did not see any negatives of feeding the biochar. Certainly molasses is commonly fed, so that combination, I wouldn't expect any negative impacts there.
Thank you. Let's see. Someone's curious about whether there are data on the use of biochar in horse feed and pastures. I'm particularly interested in knowing whether biochar can improve conditions in pastures that are prone to being too wet, which can result in serious skin conditions for the animals. So it looks like there's both a feeding question and also sort of general pasture health, soil health function. And so would love to hear your thoughts on that.
I don't have much insight there. So you're going to get outside of my beef cattle expertise or area where I'm most comfortable. So I'm not familiar with any of feeding it to horses or having horses on pasture where it's been spread. I don't know if anybody else on the webinar does. Possibly John's taken his video.
Yeah.
Some thoughts.
There are documents on the USPI website about the utilization of biochar in barns and coops and corrals. It always depends, right? You're going to assist with infiltration and respiration in the soils when implemented, but if they're in the same area all the time, if those animals are heavy, they get into the soil, and depending on how much moisture you're getting, it won't necessarily remove those concerns. You may implement, a series of bioswales and such, depending on what your drainage is like in there. But and you can certainly incorporate biochar in there, but it's just too hard to tell. Too many variables. It could be a solution in some instances, but not able to say definitively at this point. So I think the one thing I do want to reiterate is that we all in the U.S. would love to be able to feed biochar to all the animals as necessary, but until we can get that approval, it is not endorsed by anybody that's presenting this webinar at this time. So please consult your local authorities to make sure that you have approval before doing so.
Well, with that, I think we've gotten through the questions. If anybody hasn't gotten their question answered, then we would love to make sure to get that in there. Take another scan through.
Can I take Jared's
yes,
question
please do.
about
I'm just seeing
biochar remains an expensive material to source? What kinds of livestock operations? So I my personal opinion is that I think we're going to see quite an interesting application for biochar in the manure management area. So when it comes to dealing with the effluent, where maybe you're straining out the liquids from the solids, and then you're seeking to control the algae that might be growing and the biology that might be growing in the effluent, utilizing biochar there in order to reduce the methane, because as we see methane regulations increase and the need for control, and as we see the price of biochar continue to decline, it will become an instance where you have the opportunity to offset the cost of the biochar purchase in order to potentially save some money on your potential methane fines. So I think that's particularly interesting, which is one of the reasons why I'm such a fan of that biochar manure study. We are working to the state of Utah. We have a real issue with runoff in the spring. And so a lot of these dairy facilities are not too far from estuaries. And so runoff, those dairy producers can face fines up to $75,000 a day when if they have overflow going into the estuary. Well, $75,000 compared to a purchase of biochar may be a real cheap investment. So we are discussing the potential about doing some studies together where we would do exactly something I mentioned with the horse question, which is creating a bioswale using a kind of a natural process in order to do some preliminary and secondary filtration, utilizing biochar and phytoremediation efforts in order to absorb the nitrogen, all the excess nutrients before it could have a chance to run off. Another thing that we have is that our Great Salt Lake is literally dying these days, and we need the moisture. And a lot of these effluent ponds contain millions of gallons of water that is just left to evaporate. If we can find the funding to perform these studies, we may be able to recover that water, utilize it to go back into our Great Salt Lake, and then we would have a fortified biochar. I do want to point out to Jared that the use case, we have composters who are reporting the ability to sell their biochar enhanced compost for between $10 and $30 per cubic yard at an increased price of $10 to $30 per cubic yard. That's typically a compost that's fortified by about 10% by volume. So, which means you're looking about 3 cubic feet per cubic yard of compost. So that's a significant opportunity for revenue. That does tend to be in the more urban areas where compost is seen as more of a premium. And so when you sell premium compost that's amended with a premium biochar, it's kind of a more solid market, as it were. Whereas in your rural communities, it may be a more difficult sell. But I think that there's a lot of opportunity. Yeah.
Yeah, it does seem like there's a lot of opportunity, certainly in those specialty crops, those high value crops. That opportunity is already being seen. And I think we're going to find out a lot over the next years. We will be applying biochar through our partnerships for climate smart commodities on some of those farms, working with you all and looking at the impacts of that. So we hope to find out some additional information and really provide some good guidance. Okay, well, I think I want to close this out. Thank you so much to everybody who stuck around. Thanks to our partners, ARS, USBI. Thank you, Andrea Watson, for participating with us today and providing this great presentation. We really appreciate it. This recording will be on our website, and look forward to hearing from you all. So do go fill out that survey.